Welcome once again to this YouTube channel. In today's video, we're going to be solving the Cambridge IGCSE Chemistry Paper 2 multiple choice questions, and it's from February-March 2023 to variant 22. Please endeavor to share these videos with your friends so that they can also learn from content like this. So let's go straight into the questions. Right, the first question says that substance M is a solid at 30 degrees Celsius. Then the substance is heated to 80 degrees Celsius, and the temperature measures as it cools down to room temperature. So we're expected to, between which times is substance M freezing. Okay, between which times is substance M freezing. Now we go back to the details of the question. It says substance M is solid at 30 degrees. So if we trace this cooling curve, 30 degrees is going to be somewhere around here. So if we trace that, kind of points towards this direction. So if it becomes a solid at this point, that means the process of it becoming a solid must have started from in between Q to R. Okay, the process of it becoming a solid should have started from Q to R. So the answer to this is simply B. Okay, so we go to the next question. Which gas has the fastest rate of diffusion? Now, to know the gas with the fastest rate of diffusion, all we simply need to do is to get the masses of each of these compounds there given, or each of the gases given. So we want to get the mass of argon. We have to get the mass of argon from the periodic table. So we could simply consult the periodic table all the way down the paper. So if you look at argon, one of the noble gases, okay, you can see that argon has a mass of 40. Okay, so if argon has a mass of 40, so if argon simply has a mass of 40, we simply write argon, the mass of argon is 40. Then for C2H6, so carbon is 12, so it becomes for C2H6, it's going to become 2 times 12 plus hydrogen is 1, so 1 times 6. So this becomes 24 plus 6, and this is 30. So that is for the hydrocarbon. Now for hydrogen chloride, you know, chlorine is 35.5 plus hydrogen, so we're looking at 36.5. And then for hydrogen sulfide, H2S, sulfur is 32, so it becomes 1 times 2 plus 32. So if we add this up, we have 2 plus 32, which is 34. So the fastest gas here will be the one with the lowest mass. So the one with the lowest mass is going to be the fastest gas. So if you look at all the calculations, we have 40 for this, 30 for this, 36.5, and 34. So obviously the answer is B. Now the next question, there are two stable isotopes of bromine. The mass number of isotope 1 is 79. The mass number of isotope 2 is 81. So which of the statements is correct? Now the first option says the isotopes have the same number of neutrons. No, if they have the same number of neutrons, then they are no longer isotopes. So this cancels out. Okay, the isotopes have different chemical properties. Okay, of course that's no, because they have the same atomic number, they have the same proton number, so they should have the same properties. The isotopes have different number of protons. Of course no as well, because isotopes are the same number of protons but different number of neutrons. So we are left with the last option, which says the isotopes have the same number of outer electrons. Okay, which is very correct. Okay, since they have the same number of protons, so they should have the same number of outer electrons. Okay, so question 4, which statement about ions and iodic bonds is correct? Okay, so we have to read through the options and cancel out which of them doesn't really align. So let's start from option A. Bromine atoms form negatively charged bromide ions. Okay, that's actually correct. Okay. Ionic bonds form between elements in group 7 of the periodic table. Okay, not only group 7 of the periodic table, it could also be ionic bonds is between a metal and a non-metal, so that cancels out. Positive ions are formed when atoms lose protons? Of course, no. When atoms lose electrons, should be the right thing. And then potassium iodide contains negatively charged potassium ions. Of course, no. The charge of potassium ions are actually positive. So A is the correct answer. Okay, so we go to the next question. Question 5. Part of the periodic table is shown. Which type of chemical bonding is present in the oxide of F and in the oxide of G? Now, this, of course, from the periodic table, this should be group 2. This is group 3, group 4, group 5, and this is group 6. So, what kind of oxide is formed between a group 2 metal and a non-metal, which is okay, what kind of oxide is formed between, what kind of oxide does F form and what kind of oxide does G form? So group 2 is a metal, and that in group 6, which is G, is more like a non-metal. Okay, so we want to see what kind of oxide. So what type of chemical bond is present in the oxide of F and in the oxide of G. So in the oxide of F, of course, since it's a metal, is donating electrons. So we're looking at ionic. So everything covalent here is off. So we're looking at ionic because it is a metal. And then when we look at oxides of G, okay, we're looking at forming covalent bonds. Just like that is where we have elements in group 6. So we have elements like sulfur, okay, in this group. So if sulfur belongs to this group, the kind of oxide is going to form is a covalent one. So the answer to this is going to be C. So question 5 is C. Alright, so moving forward, move to question 6. Elements X and Y react to form a compound. Element X loses 2 electrons and element Y gains 1 electron. So if X loses 2 electrons, it's 2 plus, and Y gains electron is just minus. What is the charge on the ions of elements X and Y, and what is the formula of the compound? So the charge is 2 plus and minus 1. So we have 2 plus and minus 1, so that means C and D are off. So 2 plus and minus 1 for A and B. So what kind of compound will they form? So if this is sorry, let's erase this. So if this is 2 and minus, so they exchange these powers, excluding the charge. So these 2 goes down here, and the 1 in Y comes down. So you're going to have X1, Y2. So that's more like XY2. So XY2 is option B. Okay, XY2 is option B. Alright, so let's go to question 7. Which statement about graphite explains why it is used as an electrode? Of course, graphite is used as an electrode because it is inert and for the fact that it conducts electricity. So the property that enables it to conduct electricity is because it has mobile electrons by looking at the structure of graphite. Methane bonds in air to form carbon dioxide and water. What is the balanced equation for this reaction? Now, it bonds in air to form carbon dioxide and water. So we look at each of the equations to see which one actually looks like a balanced equation of the reaction. So let's look at the first option, 1 carbon, 4 hydrogens. There are 4 hydrogens. Now, there are 2 oxygens here, but there are more than 2, so this is off. So the next one, 1 carbon, 4 hydrogens here, 4 hydrogens here, 4 oxygens, 2 plus 2, 4. So without wasting time, I think B should be the answer. I'll go to question 9. The equation for the thermal decomposition of sodium hydrogen carbonate is shown. Okay, this is the equation of the reaction. Now the molecular mass, relative molecular mass of sodium hydrogen carbonate is given to 84, and the mass of sodium carbonate is 106. Now in an experiment, 2.1 gram of sodium hydrogen carbonate is heated, but not all of it decomposes. All of the carbon dioxide is collected and measured at room temperature and pressure. The total volume of carbon dioxide produced is this. So we are given the volume of the carbon dioxide produced, and then we're given this information that the volume of 1 mole of a gas at room temperature and pressure is 24. So which of these statements is correct? All right, most of the statements have to do with the yield of percentage yield of carbon dioxide and the mass of sodium carbonate. So let's work towards, we can obtain the percentage yield. Okay, let's work towards the mass of sodium carbonate. Now you have to be careful here. If you look at the question carefully, it says 2.1 gram of sodium hydrogen carbonate heated, but not all of it decomposes. So that means we cannot use sodium hydrogen carbonate in this case for the calculation, because we don't still know how much of the undissolved or undecomposed substance are still present, but rather we use the gas that has been collected completely to estimate the mass of sodium carbonate. So if you look at the stoichiometry of this equation, we're looking at 2, 1, 1, and 1 in terms of ratios. Okay, so that's the stoichiometry. So we have the volume of the gas. That means we can get the number of moles of the gas. Now remember that number of moles for the gas is volume. That's what's the volume, 0.21 divided by 24 dm3, because that's the formula for calculating the number of moles of a gas. It's simply the volume of the gas divided by 24 dm3, rather, not 20.4, divided by 24 dm3. So if you use the calculator that I'm going to use here, so 0.21 divided by 24, okay, that gives 0.00875. Okay, so this is mole, so let's start with this mole. All right, so this is the number of moles of the gas that is produced, that was collected completely. So if we have the number of moles of the gas collected completely, then we can use the idea of stoichiometry to compare with the mass of sodium carbonate that is going to be produced. So remember that the ratio is simply 1:1. So if the ratio of sodium carbonate to carbon dioxide is 1:1, according to the stoichiometry, and we obtained 0.00875, let me erase this. Okay, and we obtained 0.00875 mole for carbon dioxide produced completely. That means if it is 1:1, that means an equal amount of sodium carbonate is also produced here. So both of them will give the same value because they share equal ratios. So if we have obtained the number of moles of sodium carbonate, now let's get the mass of sodium carbonate. Remember that the number of moles is the mass divided by the molar mass. Okay, now we're looking for the mass. So to get the mass, M, we multiply the number of moles by the molar mass. So what's the number of moles of sodium carbonate, which is this? What is the molar mass of sodium carbonate? Is given already as 106. So let's use the calculator this time. So it becomes 0.00875 times 106. And we obtain 0.9275 as the mass. So 0.9275. So if we approximate this, we are going to have a close, which is A, okay, 0.93 gram. So remember that why we are simply using carbon dioxide in this case is because not all of the sodium hydrogen carbonate decomposed. So we can't base our calculations on it entirely. Okay, if we move to question 10. An electrolysis experiment is done using carbon electrodes. Hydrogen and oxygen are formed at the electrodes. What is the electrolyte? Okay, so for us to get the electrolyte, remember that we have different compounds here that can likely tell us what the electrolyte is. So let us begin with aqueous copper 2 sulfate. So aqueous copper 2 sulfate, we are looking at the cations to be copper 2 plus and hydrogen ion, and then the anions to be SO42 minus and OH minus. Okay, remember that hydrogen is above copper in the reactivity series. So in this case, hydrogen ion remains in the solution while copper 2 plus is discharged. So that makes option A not the answer, because we are looking at hydrogen and oxygen being formed at the electrode. But in this case, copper 2 plus is discharged. So that's off. Then we go to the second one. concentrated hydrogen chloride. Of course, this should tell you chloride, should tell you that chlorine is involved in this case, so B option as well is off. Now we talk about the molten potassium oxide. Okay, for the molten potassium oxide, we're looking at just K plus and O2 minus. So it has nothing to do with hydrogen, except for this other one that has to do with oxygen. Because the molten means it has been heated, but it doesn't contain water. It was just heated. So the most suitable answer is dilute aqueous sodium chloride. Okay, because in dilute aqueous sodium chloride, okay, we are having sodium ion and hydrogen ion, and then we have the chloride ion, and then we have OH minus. So this is discharged at the cathode, and this is discharged at the anode to give oxygen. So C is simply the answer to this question. Okay, so we go to question 11. Concentrated aqueous copper 2 sulfate is electrolyzed using copper electrodes. Which ionic half equation describes the reaction taking place at the cathode? Just like we mentioned earlier in the previous question, if you're looking at concentrated aqueous copper 2 sulfate, we're looking at copper 2 plus and hydrogen ion as the cations, and we're looking at OH minus and the SO42 minus as the anions. But this time we're looking at the cathode, so this either of them will migrate to the cathode. But we established that copper is below the reactivity series, hydrogen is higher than copper, so hydrogen remains in the solution while this is discharged. So for this to be discharged and it is taking place at the cathode, remember at the cathode there is gaining of electrons. So we look at equations where copper is gaining electrons, and you see that is this option, so option D. So copper 2 plus gains electron to become the copper metal. So that is that. Okay, so go to question 12. When powdered sodium carbonate and aqueous ethanoic acid are mixed, the temperature of the mixture falls. Okay, which statement about this reaction is correct? So the temperature of the mixture falls. So let's read both of the options. It says the reaction is endothermic and the change in enthalpy is negative. There is no way the reaction is going to be endothermic and the change in enthalpy is going to be negative. These are two opposite points. So this is off. The reaction is endothermic and the change in enthalpy is positive. Okay, this rhymes because the change in enthalpy should be positive for an endothermic reaction. The reaction is exothermic and the delta H is negative. This is also in line. The reaction is exothermic and this is positive. No. So we're left with two options. Now let's read again. The temperature of the mixture falls. Now for the temperature of the mixture to fall, that means it has been absorbed. And for it to be absorbed, that is simply an endothermic reaction. So option B. If it were released, then it would have been, if the temperature had increased, then it could have been an exothermic reaction, and then C will be the option. But in this case, it is the fact that the temperature has fallen. All right, so we go to question 13. Magnesium powder reacts with an excess of dilute hydrochloric acid to produce hydrogen gas. So which statements about this are correct? All right, so we look at first statement here. This first statement says that the smaller the particles of magnesium powder, the more slowly the hydrogen is produced. That's wrong, because the smaller the particles, the faster the collision, because the surface area has been reduced. So this is not it. Okay, and then the next point says that the higher the temperature, the faster the magnesium disappears. So the higher the temperature, of course, the faster the magnesium. So this is in line. Okay, the lower the concentration of dilute hydrochloric acid, the faster the rate of reaction. That's low. That's no. That's a no, because the concentration, the higher the concentration, the faster the reaction. The lower the concentration, the lower the reaction. So every option that has 1 and 3 is off. So option A has 1 and has 1. This has 3. This equally has 3. So we are just left with the correct option, which is C. So the higher the temperature, the faster the magnesium disappears. That's correct. The faster the magnesium powder disappears, the faster the rate of reaction. That's also in line. So that's for question 13. You could see how I eliminated a lot of options in the shortest time, just by reading out those points that do not align with the question. Question 14, the reaction below between two aqueous compounds X and Y is slow and exothermic. The graph shows how the rate of this reaction changes with time. A student suggests that the rate of reaction decreases with time because the activation energy decreases. No. Okay, that is not it. Okay, because if the activation energy decreases, then the rate will be slower. The speed of the molecules of X and Y decreases. And that has to do with the temperature anyway. Okay, so let's read the third point. The concentration of both X and Y decreases with time. I think that's a better view to why the rate of reaction decreases. Okay, so this is off. So 3, it should be the correct answer for question 14. So for question 14, the third one only is the correct one. Now we go to question 15. Hydrogen reacts with iodine to form hydrogen iodide. Which statements explain why the reaction is faster when the pressure is increased at constant temperature? Okay, so let's read again the options. At higher pressure, the molecules are moving faster. No. Okay, no. That is not the at higher temperature, at higher pressure rather, the molecules are not moving faster. Okay, because the molecules are very close together. Now the next one, the next point says at higher pressure, more of the molecules have the required activation energy. Third point says at higher pressure, the molecules are closer together. Okay, this is correct. At higher pressure, the molecules collide more frequently. This is also correct. So this is off. At higher pressure, more of the molecules have the required activation energy. No, that has to do with the temperature. So the 3 and 4 are the correct options here. So option D is the right answer to this. Question 16. Ammonium sulfate is used as a fertilizer. It is made from ammonia and sulfuric acid. So it asks to fill in. The dash is made by the dash process in which dash is used as a catalyst. Okay, let's look at it. Ammonia cannot be made by the contact process. That's off. Ammonia and the Haber process, correct, but the catalyst here is wrong. Sulfuric acid is made by contact process, and this is the correct catalyst. Sulfuric acid by Haber process, no. Iron as a catalyst, no. So option C is the correct one. The reversible reaction shown takes place in a closed system at constant temperature. So when the reaction has reached equilibrium, more of this is added. After addition of T, which other substances increases in concentration? Okay, remember that this has not been touched, but more of this was added. That means there's a likelihood that there is more of this still in the system. So for that, we're going to have more of P, Q, and R as the product. So that's option C. 17 is C. Okay, in which reaction is the underlying substance acting as a reducing agent? Okay, for something to be a reducing agent, that means it has been oxidized. So let's check each of the equations to see which one is oxidized. Okay, which of the underlying one is actually oxidized. So just by looking at it, you see that carbon monoxide, which happens to be the carbon there happens to be oxidation, has to have an oxidation number of +2. But in the reactant side, but if we move to the product, it moves from +2 to +4. Okay, this is an oxidation, increase in oxidation number, and that means this, since it's oxidized, it means it is a reducing agent. But let's check for other options. But A should be the correct one. But let's check and confirm if others actually follow that pattern. So in this case, option B, carbon moved from +4 this time to +2. So this is reduction. Okay, and that is more like an oxidizing agent. Okay, so option B is off. Now for the next one, we see that copper moved from +2. Copper moved from +2. For that's for the third option, option C, move from +2 to 0. So this is also reduction. Okay, so of course, if we check others, you see that the principle follows. So A is the answer to that. All right, question 19. Question 19 says that an aqueous solution reacts with a solid. The products are an alkaline gas. Take note of this: alkaline gas, a salt, and water. What are the aqueous solution and the solid? Okay, so for something to produce an alkaline gas, all you need to do is to write the equations for each of these reactions to see what it will produce. For the first one, sodium hydroxide, let's erase this quickly so that we will not dwell too much on this question. So sodium hydroxide, NaOH, plus magnesium carbonate, which is MgCO3. So in this case, of course, you're going to produce sodium carbonate. Okay, you're going to also produce carbon dioxide and okay, and we're going to produce magnesium hydroxide. Okay, so we're going to produce that magnesium hydroxide. So just by writing the chemical equations, you'll be able to obtain or predict what will likely occur. But if you look at the question, it's talking about alkaline gas, a salt, and water. Okay, so in this case, there is no water produced, so this is off. So let's look for a reaction that is likely going to give water. In this particular reaction, to water will not also, there's no likelihood of water being produced. So let's come to hydrochloric acid and ammonium chloride, also no likelihood of water being produced. But if you look at this, sodium hydroxide and ammonium chloride, there is a likelihood for you to produce water. There's a likelihood for you to produce a salt, which is sodium chloride, and there's a likelihood for you to produce the alkaline gas, which is ammonia. So in this case, D is the correct answer. Butanoic acid partially dissociates in aqueous solution. Which row about butanoic acid is correct? So for something to partially dissociate, it means it's a weak acid, and that means the pH has to be quite close to the neutral in terms of the acidity. So look at this, B is closest to the neutral position from the acidic point of the pH scale. Copper 2 sulfate is prepared by adding excess copper 2 carbonate to sulfuric acid. So why is an excess of copper 2 carbonate added? Of course, to ensure that all of the acids have reacted. That is why you keep on adding excess of copper 2 carbonate. This is under salt preparation, to ensure that you use up all the acids. Part of the periodic table is shown. Okay, which element has 2 electrons in its outer shell and 3 electron shells? For an element to have 2 electrons in the outer shell, that means it belongs to group 2. That means this is our focus. This is off and this is off. Okay, so the element belongs to group 2, and then it has 3 electron shells. For it to have 3 electron shells, okay, that means we are looking at it belonging to period 3. So this is the first period in terms of horizontal, period 1. If you trace it all the way to this point, that's period 1, period 2, period 3. So our answer is simply C, because this aligns with 3 electron shells. Okay, we go to question 23. Elements in group 1 and group 2 show the same trends in their reactions with water and in their density. So which row shows how the properties of barium compare with calcium? Now, if you check the periodic table, you see that barium and calcium, they all belong to group 2. And then from the knowledge of group 2, we see that their reactivity, you see that their reactivity is simply faster, and their density is also higher as we go down the group. Okay, so as we go down, in terms of reactivity with water and in terms of their density, is simply increasing. So this is A. So A simply answers that question. Okay, so going to question 24. Which pair of compounds shows a transition element in 2 different oxidation states? Okay, so a transition element in 2 different oxidation states. So what we need to do is to look at each of the compounds to determine that. So if you look at chromium, in this case, Cl2O3, so for this chromium, it means chromium has 3 plus, oxygen has 2 minus. And the same thing applies to the second compound. So the oxidation number of chromium in the second compound is 3 plus, and sulfate is 2 minus. So there's just an interchange as usual. So if we go to option B, copper there is copper 1, okay, and then the other part is copper 2 plus. So there are 2 different oxidation states of copper there. So simply B is the answer to that question. Which description of brass is correct? Okay, when you talk about brass, you know, it is simply copper and zinc, a mixture of copper and zinc. So copper and tin is simply bronze. Okay, and remember, it has to be a mixture, it's not a compound, so it's a mixture. So this is for bronze. What is the symbol of the metal used in the manufacture of aircraft because of its low density? Of course, this is a straightforward question. This is in aluminium. Now, question 27. Which substances react to form hydrogen gas? Of course, calcium and water will react. This is correct because calcium is way above hydrogen on the reactivity series. Okay, silver and dilute hydrochloric acid, no, because silver is below hydrogen on the activity series. Magnesium and steam, yes. Zinc and dilute, yes. So 1, 3, 4, A. This just has to do with the reactivity series. Question 28. Coke, which happens to be carbon, and limestone are two raw materials, right, used in the extraction of iron and hematite. Which type of reaction occurs when each substance is heated during the process? Of course, you know, coke goes in there as more as a reducing agent, okay, more as a reducing agent, and then the limestone breaks down to produce calcium oxide and carbon dioxide. That's from the extraction of iron. So the best option here is the most suitable option rather is B. Some combustion reaction produces pollutant gases. Which reactions produce a pollutant gas that is not present in clean dry air? Now if you look at the composition of clean dry air, you're looking at water vapor is present, carbon dioxide is present. So which of these other gases are not there? This is not present and this is not present. So for question 29, we're looking at those options that contain that. So we see 1 and 4 are the two gases, pollutants that are not present. Question 30. 1 mole of alkane produces some 2 dm cube of carbon dioxide when bound in excess oxygen. Measure at room temperature and pressure. What is the gas that was bound to produce 72 dm cube of carbon dioxide? Okay, so in this case, first we need to get the number of moles of carbon dioxide, and that can give us a hint on the gas that was bound. So to get the number of moles, just do 72 divided by 24 dm cube. That's the formula for calculating number of moles of a gas. So we do this, you're going to have 3 as the number of moles. So if 3 are the number of moles, so you look at your options, which one is likely going to have 3 carbon atoms? You look at, then you see that butane has 4, ethane 2, methane 1 carbon, but propane has 3 carbon atoms. So that is simply the easiest way to solve that. Question 31. The structure of organic compound X is shown. What is X? Now, when naming esters, you first name this group. Okay, you name the group, this group. Okay, after naming this group, then you name this. Okay, so you name this first, then you name this. So if we name this, it is methyl. Okay, methyl because there's just 1 carbon, so it's methyl. Methyl. And if you name this, there are 2 carbons, so it's ethyl. So methyl ethanoate. So methyl ethyl here. So it's methyl ethanoate. So that's option C. That's for question 31. All right, so for question 32, what is the structural formula of the compound formed in the addition reaction of propene with bromine? So propene is something like this. All right, so the hydrogens attached to these carbons. There's 1 here, there's 1 here, there is 1 here. So when you add bromine, what bromine does is break this double bond and attaches 2 of the bromines to each of the bond in between, the 2 carbons that are in between the bonds. Okay, so it attaches the bromine to 2 carbons in between the double bond that was broken. So when we do this, we're going to have a new structure, and then we can now find out what the structure is going to look like. So now that the bond has been broken, we have something like this, a single bond. Okay, and there is the hydrogen here. So in this case, our formula, if you want to pick it from behind or you want to pick it from the front, either way, we're going to have CH2Br. That's for the first one. Then for this, you're going to have CHBr, and then for the last one, we're going to have CH3. Okay, so if we look at this, which of the options rhyme? Okay, CH3, CH, Br, CH2Br. So option A rhymes with that answer. Okay, so just know that whenever an alkene is reacting, additional reaction with bromine or halogen, the halogen breaks the double bond and attaches two of the halogens to the carbon atoms in between the two double bonds. Now, ethanol is produced industrially by fermentation and also by catalyzed addition reaction involving steam. So which role describes one advantage of each process? So is that the reactant is renewable and it's a continuous process. Okay, so that's just it. Carboxylic acid reacts with alcohols when warmed with an acid catalyst. What type of substance is formed in this reaction? Of course, from your knowledge of organic chemistry, an ester is formed. Nylon is formed by condensation polymerization. So which structure represents nylon? So for you to look at the polyamide group, okay, you have to look out for the polyamide group. And where is the polyamide group? So this is that polyamide group. Okay, so the polyamide group gives us the answer. So that's the C. Okay, so the polyamide group is what we look out for in this question. So that's for question 35. Okay, now moving forward, which structure represents the repeat unit of the addition polymer formed from but1-ene? Now when you look at but1-ene, okay, let's see if we can draw the structure. Let's see if we can have a space to draw this so that it doesn't really consume too much space. So but1-ene has 4 carbon atoms, so there are hydrogens here. There's an hydrogen. Okay, let's do this properly so that it's clear enough. Okay, so let's see if we can bring this down a bit. Okay, so this is but1-ene, right? So there's hydrogen attached, hydrogen here, hydrogen equally here, and there are 2 hydrogens here. Okay, and there's just 1 hydrogen here. So when the repeat unit is simply the fact that this double bond is going to break. Okay, this double bond is going to break by the time it goes into the polymerization. Okay, and by the time the double bond breaks, okay, you can see that there are just 2 hydrogens here. So what we are expecting is something like this. Okay, the 2 hydrogens of course will be attached as usual, and then every when we have the second hydrogen, which is here already, okay, but it has the H, so we draw the H, and then when there's a breakage like that, when there's a polymerization, what we do is we add up other carbons that are after these 2 carbons. So this is CH2, CH3. So CH2, CH3 is C2, 1. This is the first carbon, second carbon, 1, 2, 3, 4, 5. So 5 hydrogens. So it's C2H5. So this is how the repeat unit is going to be, and that is why A is the answer. So when you're looking at repeat unit of an addition polymerization, look at where the bond breakage is occurring first, okay, which is between these 2. So we have these 2 there, and then what are the atoms attached to the carbons? The 2 hydrogens for this left carbon, and for the right we have 1 hydrogen here, and then every other group will become what is attached below. Please take note of that. Okay, so question 37. 2.0 gram of powdered calcium carbonate is added to 50 centimeter cube of hydrochloric acid. So which apparatus do you need? You want to measure mass and you want to measure volume. So of course the most suitable apparatus is the balance and the burette are the 2 suitable apparatus for measuring the mass. Okay, so All right, so let's move to question 38. The diagram shows a chromatogram obtained from the colors of 3 different suites, X, Y, and Z. How many different red dyes are present in the suite? Now, we have one red dye here, which is the same thing as this red dye. So that's 1. And then we have the second red dye, which is the same height as the other dye. So there are simply 2 red dyes there. Question 39. The mixture contains sand and an aqueous solution of sodium chloride. Which processes are used to obtain the sample of solid sand and the sample of solid sodium chloride from the mixture? So we have several processes here. This is crystallization followed by filtration, filtration followed by crystallization. So in this case, you have to filter first and then you crystallize to obtain the salt. A student tests an unknown compound M. It produces a lilac flame. Now when you have a lilac flame from a flame test, that should tell you that it is potassium. So that means option A and B are off. Now, it then produces a gas which turns lime water cloudy. So, of course, the gas that turns lime water cloudy is carbon dioxide. That means it is simply potassium carbonate. So, those are the answers to those questions. Continue to subscribe and learn from content like this and share with your friends so that they can equally learn. Thank you for watching.
I want to talk about a very important YouTube channel called HR Tech. Trust me, this YouTube channel is a giveaway. It's loaded with IGCSE. Trust me, is a giveaway. This channel is helpful for your group studies, your personal studies, and it has a proven track record of producing excellent results. So do me a favor, click on the subscribe button, okay, and share this YouTube channel with your friend. Trust me, that will be the best gift that you're giving to them. Thank you very much, and I'll see you in my next video.